Hello everyone, hope you are doing well. In this video, we will be discussing Introduction to Machine Learning and what libraries that are required in machine learning language. Table of contents are what is ML, about big data era, types of machine learning problems, steps to solve machine learning problems, data gathering, data pre-processing, feature engineering, algorithm selection and training, making the predictions, uses of ML, advantages of ML, disadvantages of ML, libraries for ML, and the summary. So first topic is like, what is machine learning? You might be interested in knowing what basically ML is. It's basically method of teaching machines to learn things and improve predictions or behavior based on data on their own. Machine learning is about extracting knowledge from data. It's a research field at the intersection of statistics, AI, computer science, and is also known as predictive analytics or statistical training. Machine learning algorithms are used in wide variety of applications such as medicine, email filtering, computer vision, etc., where it is very unfeasible to develop conventional algorithms to perform the needed tasks. Here you can have a glimpse of this image where you can get all about machine learning, unsupervised, supervised, new data, and many more things. Now proceeding towards the topic, the big data era. It involves three things: data, devices, and services. Data we know, like it's available everywhere around the world, like everybody can access the data. Everyone has several GBs for free, and hardware are more powerful and cheaper than before because mostly work is reliable on software. Devices. Everyone nowadays has a computer that is fully packed with all the features like sensors, GPS, cameras, microphone. Now coming to the services. Cloud computing, online storage infrastructure as a service. Some user applications are Facebook email, Facebook Twitter. Now you can have a glimpse of this image. It depicts all the services about big data era like Skype, Flickr, Twitter. Through this wheel you can get insights about all the things which are included in this big data era. Now proceeding towards the types of machine learning problems. These are mainly categorized in three types: supervised learning, unsupervised learning, and reinforced learning. First is supervised learning. Here we have to achieve a target variable. We can learn through examples of which we know the desired output, like what we want to predict. Examples are from an image, if we want to predict is it a cat or dog, if emails sent to us are spam or not. We have to predict the market value of houses, like house price prediction, cancer prediction are examples of supervised learning. After that, it's categorized into classification and regression. In classification, output is discrete variable. Like example, we have cat or dog and we want to predict is it yes or no. Is it cat? Then yes. If it is not cat, then no. Then regression. In regression, output is continuous, like the target variable is continuous. Example, the price, the temperature, these are continuous values. Now proceeding towards the unsupervised learning. In unsupervised learning, there is no target variable, there is no desired output. We learn something about the data.latent relationships. Example, if we want to find out the anomalies in the credit card usage of customers, so we can use the unsupervised learning. Now comes the semi-supervised learning. It basically falls between the semi-supervised learning basically falls in between what? The unsupervised learning and the supervised learning. Some of the examples are missing training labels, yet many machine learning researchers have found that unlabeled data, when used in conjunction with a small amount of labeled data, can produce a considerable improvement in learning accuracy. Now comes the reinforcement learning. Reinforcement learning is based on system that when machine learns correctly, it is rewarded, otherwise penalized. Due to its generality, the field is studied in many other disciplines such as game theory, control theory, operations research, information theory, simulation-based optimization, multi-agent systems, swarm intelligence, and many more. Example is an agent interacts with an environment and watches the result of interaction. The environment gets feedback via positive or negative reward signal. Like if it's positive, it's rewarded, otherwise penalized. Now you can have a glimpse of this image which depicts all the types of machine learning: supervised, unsupervised, reinforcement. Proceeding towards the next topic, that is steps to solve ML problems. These are 5. Data gathering is basically deals with collecting data from various resources. Data pre-processing deals with cleaning the data to have the homogeneity. Feature engineering involves making your data more useful. Data structure and algorithms involve selecting the right ML model. Now, making predictions, we evaluate the model. Next topic is data gathering. Data gathering is basically collecting data from various resources, might depend on human work, like manually labeling for supervised learning. Domain knowledge may be experts. May come for free and sort of. Example is the machine translation from one translation to another. The more, the better. Some algorithms need large amount of data to be useful. Example, neural networks that are used in deep learning. The quality and quantity of data dictate the model accuracy. Now comes the data pre-processing, like where data is wrong, like what is wrong with the data. Some of the common things included in this are missing values, outliers, bad encoding for text, wrongly labeled examples, biased data. We have to fix the data or remove the data. Now, from this image, you can have a glimpse of data pre-processing, which is divided into 3 categories: data cleaning, data transformation, and data reduction. Data cleaning involves missing data, noisy data. Data transformation involves normalization, attribute selection, discretization, and concept hierarchy generation. And data reduction involves data cube aggregation, attribute subset selection, numerosity reduction, and dimensionality reduction. Proceeding towards feature engineering. What is a feature? It is basically an individual measurable property of a phenomenon that is being observed. Our inputs are basically represented by a set of features. For example, to classify a spam email, features could be the number of words that have been used, like C3HAN2D, like this. Number of the email, language of the email also plays an important role, like 0 for Spanish is used and 1 for English. The number of emojis, like on these 3 categories, we can classify a spam email address. Now extract more information from existing data, not adding new data per dataset. Making it more useful with good features, most algorithms can learn better and faster and are more reliable. It can be art. It requires thought and knowledge of the data that is being used. 2 steps are there, like variable transformation. Example, that data into weekends, date into weekends, and normalizing. Okay. Now in this comes the feature creation. Example, n grams of for texts if word is capitalized to detect the names, etc. Now here you can have a view of the feature engineering. 2 classes in coordinate system are there, tangled, and 2 classes in polar coordinates are transparent. Coming to the algorithm selection and training, these are categorized as in supervised. We have linear classifier, naive Bayes, SVM, that is also called support vector machines, about decision tree, random forest, KNN, that is K nearest neighbors, neural networks, that is used in deep learning. About unsupervised learning, PCA, K-means, DBSCAN and TSNE are used. Now coming to the reinforcement learning, in this we have SARSA, SARSA lambda and Q-learning. The goal of the training is making the prediction correct and often as possible. Use of matrices are used for evaluating the performance of the data and comparing solutions. Hyperparameter tuning, it's more an art than a science. So wish you all a happy learning and thanks for watching this video. Thank you.